So now we're going to take a look at an overview of parabolas. So these are just overviews so that maybe if you were given an equation, you could at least draw a rough sketch or understand a little bit about these shapes. So a parabola is a set of points that are equidistant from a fixed line called the directrix and a fixed point called the focus. So here's my set of points, and whenever I pick a point, this distance has to be the same, or this distance has to be the same, or this distance has to be the same as I go. So these are not the same as each other, but anytime I draw the two lines have to be equal. There's two different ways that you could write a parabola equation. If it has a vertical axis of symmetry, that's our old friend, the parabola. If it has a horizontal axis of symmetry, that's a sideways parabola that's not a function anymore. If it's going to have a vertical axis of symmetry, it's going to have x squared in it. X minus h squared equals 4 times p y minus k. hk is still the center or the vertex of your parabola. For p is this value. How far from vertex to directrix, or vertex to focus, and the 4p value is your focal width of the parabola. So we're going to see what that means in a minute. If p is positive, it's going to open up, and if p is negative, it's going to be concave down. What if it's a horizontal axis of symmetry? Well, then it's going to be the y value that's squared and not the x value. So this is the only time when your equation will have one of the terms that's squared and one of the terms that's not squared. For a circle, ellipse, or hyperbola, both x and y have to be squared in the problem. This time, when p is positive, it opens to the right. So positive is either concave up or right, and when p is negative, it's either going to be concave down or opening to the left. So here's an example when we've got a horizontal directrix because we have a vertical axis of symmetry. I'm going to show you what horizontal directrix means in a minute, but x is being squared. So the coordinate of my vertex is right 3, up or down 0. The p-value, if 4p is 8, then p by itself is just 2. I have to divide by 4. All right, I'm going to do these two things at the end. So let me show you how to plot this. The coordinate of the vertex is at 3, 0. It opens up because p is positive. So that tells me that my graph is going to open up, the focal point is going to go here, and the directrix is going to go underneath my parabola. If the p-value is 2, you go up 2 to the focus and down 2 to the directrix. And if your 4p value is 8, from the focal point, you'd go half, 1, 2, 3, 4, 1, 2, 3, 4, so that the total focal width of your parabola is 8. So this is a little bit different than how we graphed quadratics in the past when it was x squared, like 1, 1, 2, 4, 3, 9. This time the 4p value is the focal width. And that's how you get these other key points on this graph of a parabola. If you put this into standard form or vertex form, it would follow the same rules. So you could graph this in another format. We're just practicing in conics form. So the equation of the directrix would be y equals -2, and the coordinate of the focus would be 3, 2. So let me show you another example. We've got x squared over here. So that tells me again that this has to be vertical axis. Vertical axis of symmetry, so horizontal directrix. This time it's going to be concave down though. So my focal point is going to go here and my directrix is going to go here. My vertex is at 0, -3. So I'm going to plot my vertex. My p-value, if 4p is -16, then p by itself has to be -4. So I go down 4, 1, 2, 3, 4 for my vertex, and 1, 2, 3, or for my focal point, and then up 1, 2, 3, 4 for my directrix. For my focal width, it's 16. So I'm going to plot 8 in either direction around my focal point. So this is a pretty wide parabola. The equation of the directrix would be at y equals 1, and that focal point was at negative 7, right? Okay, so let's do just one last example together to give you kind of an overview of parabolas today. So this time y is being squared. So your axis of symmetry is horizontal. That makes your directrix vertical. If your p-value is negative, it's going to be a sideways opening parabola to the left. The coordinate of your vertex will be at 0, -2, which is here. The p-value, or 4p, is -4. So p by itself would be -1. So my focal point will go here and my directrix will go behind it. So 1 in this direction and 1 in this direction. The total focal width is 4. So I'm going to split the difference and 1, 2, go 2 on either side for a total focal width of 4. So the equation of my directrix is at x equals 1 and my focal point was at 1, -2. So that was a lot to take in. It was just supposed to be an overview of hyperbolas and parabolas. And, if you leave with just a general sense of how to graph those, that's great.